Hey guys, this is Pratik here. Welcome back to another video. In this video, we will try to cover the java.util.Optional class. We will go through what all are the important methods and how we can use it in real-time scenarios. So let's get started. So let's quickly first look at the optional class and what all methods and constructors are there. Let's start with the constructors. So if we see the constructor, we see that they are private constructors, so which means that we cannot instantiate them just like with a new operator. That which also means that we there will be some static methods to initialize it, like this one. Empty is one, then we see off is another, then off nullable. So these are the three constructors. So let's see how we can use that. So so in order to create an optional type, optional, let's say if I do a string uh, optional str, so what I can do is optional dot, the first one is empty, so this would actually create an empty optional without any value. Second one is like off, this is like uh, this should be used when we know the value is not null, otherwise it will throw null pointer exception. So what I mean here is so let's say if I just, or if I just simply execute this one, this will work fine in this scenario because the value is John Doe. Now if I just set it to null, it should throw null pointer exception. See, this is a null pointer exception. So the reason is, if you look into this, it calls this constructor. From this constructor, it calls this object dot require not null on this value. And remember, we are this value. If the value is null, then it comes to this. There is this null, and it throws this null pointer exception. That's the reason. So optional dot off should be used whenever we know that this value is not null, and there is another one which is off nullable when we are not sure whether it is nullable or not. If we run the same code with this method off nullable, no exceptions here. So these are the three ways. If you want to create an empty one, optional, then use the dot empty. If you are sure the value is non-null, then create with directly off, and if off nullable if you're not sure. Now let's move on to the important methods, which are like get and is present. These two are the traditional methods, like the caller will use it in a traditional way. For example, uh, eh, we can use it like this: if optional dot is present, so it returns a boolean and we can handle it. So let's say if you want to do is print. Now here we can actually use the get method to return. So get method actually returns the value which is stored in optional. So in this particular case, whatever value is stored, let's say if I just remove this thing, in this particular case this string is stored in the optional value. Now when we call this get, it should return this particular value. So if I run this thing, I should expect a sysout with this name. Here it is. Now these are the normal way of using, like is present, which returns a boolean, and get returns the value. Now let's get on to the little more interesting methods, which is if present. So let's use the if present. So the if present method actually takes a lambda. Let's see, if you see a consumer function, we can pass a consumer function. In Java, we know a consumer function is one which takes an argument and return type is void. Let's quickly check the consumer function here. If you see, we have this accept method which takes a type t, and it's a void type. So if you have to use an if present, so we have to pass a function which is of which has a return type of void and accepts an argument. So a sysout can be a perfect case. So what we can do is we can say that n and print n. So This takes the argument n, which is passed over here, and it's void. So we passed a consumer here, it printed the name. Now we can also do the shorthand notation like this. So this means that whatever argument comes, which is basically this name, in this if present, it is directly passed on to this println method. So if I run this, you should expect the same output here. Here it is. So this is one short hand way to do write this. Moving on to the next optional method, which is filter. So if I so the filter expects a predicate like predicate test. So let's say n dot starts with, let's say, yeah, or let's say goh, something like this. So if uh, so we have provided a condition check here. So if the condition passes, then it will move on to the next whatever we have defined here, anything. So it can be like this on and on, but filter basically, if condition is true, then only it will move on to the next piece of instruction. So here it should, because this name starts with goh, so we should able to see the same output. But if I just delete one character from the start, we should not see any output there, as we can see. Moving on to the next function, which is the map method. The map method can be used like to uppercase. So whatever name is sorry, whatever name is passed here, we call the to uppercase on that one. Also, we can use a shortcut method like string colon colon to uppercase like this, which also means the same thing. So if I run this thing, I should expect this all to be in caps. Let's see, the output is in caps. So this is the map method. The next one is flat map. So the difference between map and flat map is like, if we see the signature, if you see the mapper, which is the second argument here, the mapper, if you see anything which extends u, but here it is an optional of u. So what it means is uh, the mapper for flat map, I think it will be clear here. So if I just keep it like this, you see it gives me compilation error. So what we have to do is like this. So earlier it was like n.2 uppercase. So for flat map, we have to wrap this thing in an optional like this. So the mapper for map versus flat map is different. For flat map, the mapper has to be wrapped within an optionable thing. For map, it is not required. So if I run this thing, it should give me the same output here. So that's the difference between map and flat map. Now moving on to this set of three methods, which is or else get, and or else throw. We'll see one of them. So let's start with or else first. Or else. So here we can provide some default values here. So if I just run this thing like this, uh, and if we just set it to null, which means that if this value is null, which in this case will be, then it should return a default name. If I run this thing, I should expect an output of default name like this. Now if I just remove the null thing, I should expect the name, no, not the default one, like this. Now the second one is or else get. So or else get expects a supplier thing, just opposite to the consumer, which we used in the if present one. So supplier, let's quickly check the supplier interface here. So it has a get method, no argument, but returns the type t. So which means in the or else get, what is the return type? Return type is t. And what is the argument? Void. So for void argument, we define a void like this, and return type is string. So because we are dealing with optional, not string, so let's give some default name like this. So if I run this thing, and this time it will print the name, and if I just make it null, we should expect to see this default name like this. Now the last one is or else throw. So or else throw is like, if you want to, if the value is null, if you want to throw some exception like this. So since this value is null, if we run this thing, we should expect to see this runtime exception. Usually we would be creating our some custom exception, and we should be throwing that one like this. uh, X extends run time exception, and we throw this like this. So this is what in real time we should be doing. You see custom exception. Now, so we covered, and after that we have the normal equals and hash code, which we are not and toString, which we are not going to cover. These are self-explanatory. So now what we'll see is in real time, how real time scenarios, how we can use this optional class. What are the use cases? I'll just go through them. So for example, if we have, let's say, if we have an interface, uh, let's say customer DO, and let's create a class customer which has name and a constructor like this, and this interface returns customer get customer by ID, takes string customer ID like this. Let's say we have this interface like this, and an implementation class implements customer DAO like this. Let's quickly add the implementation like this. And then in the return time, what I'm trying to simulate here is like, sometimes it may happen that the customer ID is not present in the DB. In that case, what we do is we would return null like this. So what, in order to simulate this, I'll use just random dot next int. Let's say we give it bound of 3, so it will, like, it will generate 1 and 2. And what we do is we do this modulus of 2. If this is 0, means it's an odd number, even number, otherwise it's an odd number. So what if it's an even number? Let's say we return new customer, let's say some name. If it is odd number, then let's say we return none, just to replicate the real life scenario if the customer ID is not present in DB. So now a caller can be like this, customer DAO, customer DAO MPL, let's say custom dot get customer by ID, give some ID dot name. So we want to print the name of the customer here. Now what will happen is, if I run this, some of the times it should print the name, some of the time it should throw null pointer exception. Let's see what I mean here is, this time we got some value, again we got some value, again we are getting the values all the time. Did I miss something? If it is 0, this is null. Yep. So what a coincidence we got here. So this gave the null pointer exception here. So what I mean, uh, the problem here is that we are getting this this exception, which is not good. So the better way to design this API would be, instead of this returning customer, it should return optional customer like this. Similarly in the implementation and off, here we are using the off because I know this is not a, like, it's a non-null, not null value, and here it will be dot empty like this. um, and in the caller it will be very simple, like dot, we can use the if present consumer if you want to print the name, like customer name. Now no matter how many times we run, we should never see this null pointer exception. So this time, see, we got empty, this time we got some name. So the idea here is to avoid all these exception practices by providing the caller an opportunity to handle null pointer exceptions. So similarly in other APIs, while designing other APIs, for example the REST API, where you return the same thing if it were a REST endpoint, similar things could have been done. And let's say one other example would be if we are designing a REST controller and if this ID is not present and we want to throw some resource not found exception. So we can use in the caller here like this, or else throw this one, uh, throw some resource not found exception, like that. So this way the caller, if we don't do it this way, the traditional approach would be to do something like this. If this, just store it somewhere, customer equals null, then do something, handle it else. So this would be the traditional approach without this optional thing, but uh, this optional thing is more concise, looks elegant, so we should try to use this approach whenever possible. So that's it for now, guys. I hope you enjoyed this video. See you guys. Bye bye.